Hello, welcome to episode 159 in this series where I'm programming an NES game live on Twitch from scratch, now complete with new lighting. First time chat from viewer Richard Thames, like the Thames River. Well, welcome. Hello. Alright, so yeah, now with new lighting and higher production value, because they were inexpensive on Amazon and they came with the diffuser, so I thought, you know what, we'll give it a shot and can use them for work too, because we do a lot of video conferencing. So yeah. The last time we were reorganizing the code quite a bit, and we got everything essentially back to the state it was before we were reorganizing all the code. In terms of functionality, which is good, but obviously we have some problems related to that functionality. So our title screen is got a bunch of junk because I'm not clearing out the tiles that come after it, and also the palette is wrong. I believe in other streams I have gone through and modified some of the colors, and yeah, and you can see the rest of the title emerges. This is just a placeholder anyway, that's why I'm not super concerned about that. The more important thing is that we have this issue where the metatile that's repeating is not repeating. Well, first of all, it's not repeating correctly. Second of all, it's not repeating in the right place. And then third of all, when you start, it's not filling the whole screen with the metatile. So I'm trying to get this into a size that's big enough, but also still proportional. Oops. What did I do? Palette viewer. Oh, it's Alt. Right, so I think probably what I want to start with is fixing the fact that we're not loading the whole screen with that tile, but also take a look at why it's not updating the tiles off the top of the screen. I have a feeling that's a pretty simple thing. Like, it works fine for the regular map rendering initially, and then once we go back into repeat scroll, it's no good. So it's probably something to do with the memory address that we're using to tell the game where to write the first row of tiles that we want to update. So yeah, so there's that. And then the other thing we didn't do is we have these lookup tables now which need to be generated based on this entity lookup. And actually, one of the things that I had done was I had moved the objects to be separated out, but it turns out that we don't need that. So I'm going to put that back, which is good because it makes the file a little bit simpler to deal with. So this was 1, I believe. This doesn't affect anything. Oh, it was 2. It doesn't affect anything. Wait, how is it 2? Explode bullet. Oh yeah, okay, player, and then that comes, enemy comes after cloud. It doesn't affect anything in terms of what we're doing right now, but I just wanted to remember to make that change because we don't need that separation here anymore. Okay. We can close that. But yeah, so eventually we got to go back to the export tool, have it generate a table that corresponds to these process calls and the entities that match. And what'll be good is that in the project file we have the list of entities. If I add an entity now and forget to create a process for it, this code will not assemble because it will have a new, if I add something called, process whirl -1, right, or whatever. Actually, I believe that's the proper spelling, but anyway, and then we try to build that. Obviously, that's not going to build because process world doesn't exist. So that'll be a good thing also because it's going to make sure to check the code and, catch any sort of things that are missing in the game. Because we added an entity but didn't actually define the code for it. So that's actually good. We can... I'm actually just going to close all of this because there's just a ton of stuff that's open. And what we really want is load level right now. So right now, when we do the repeat scroll mode, we are not loading the whole name table with tiles. So if we go look at that, you can see we've loaded some of the tiles here, but we haven't updated this stuff that's just junk. Now when we draw for a map that is a full map, we do the calculation to find where the map begins and then just fill in the whole name table with the additional tiles we need. So I'm just trying to find the beginning of that code. So here's load full screen. So we're loading in the number of max rows, and then we're subtracting. Yeah, so then we're subtracting a row and multiplying by the number of metatiles horizontally across, and that gives us our position within the data that we need to fill it in. Now, for repeat scrolling, it's actually a lot simpler. The main thing we need to do is we need to determine if that's anything we actually want to do for repeat scroll mode. So it's funny, this it's actually bigger than I expected it to be, but it's not that bad. All right, so when we compare this here, then we just store that we set up the camera position based on what the repeat scroll mode camera position says it should be. This is always 0 because our lookup consists of one entry every time, right? And then BG loop metatile, right? And then set the address for the lookup to row_min plus y because that's where our metatile lookup lives, right? And then we're done. So, okay, so what we need to do is we need to determine, before we go to done loading tiles, if we should be forcing the map to get drawn or not. And we can use param 3 like we were with the normal map to do the same thing. So if it's 0, we're going to blank out the screen. So where is that code that we were just looking at here? So this is our offset into the map data in param 2. We should probably, you know what? Are we saving that somewhere? I wonder if that's what's causing some of the problems we're seeing. Load level. Who's calling that? JSR load level. Load new game. Load level objects. Load level. Next level offset. Okay, so we are doing that. Process game. Okay, good. Alright, I thought we might have been storing this off somewhere. I just couldn't remember because it was a while since we looked at that. So, alright, let's go back. That's good. There still may be a problem with that that's causing the issue, but that's better than the fact that I thought we were not saving that off explicitly. So, load param 3, and then branch if not equal. So if it's not, let's do this. Branch if equal to here. Oh, wait. Our anonymous label. What is this doing? This is checking. Okay. We're gonna name this to next map mode check 1 in case we have other ones. I should not have made that an anonymous label. Next map mode check 1, or I guess technically it's 2 because the first one was the one that's up here that we are then skipping to this one for. Okay. So this is our branch of equal. So if it's 0, yeah, no, sorry. If it's 0, we want to do something. Otherwise, we're done. So param 3 is 0. So we need to force load the level with our metatile, or repeated metatile. And so one of the things I mentioned was a problem with the way our code was working before, which we'll look to fix now here, is that it was only using one tile for everything. It wasn't actually looking up the metatile the way that it probably should be. So let's get that. Well, let's do this first. Let's just load the background, and then from there we probably need to fix the memory location that the background is writing to, because I don't think that's being set at all. I know there's a variable that I believe points to the next location in the PPU memory. I have to look at where that is. But that definitely will cause a problem if we're not doing it properly. Alright, we'll worry about that in a second. So we have this BG loop metatile. That's the background loop metatile we're using. We're just going to use the value straight up for now, just to get the clearing logic working. So what we want to do is we want to load a 2002, right? That clears the latch, and then we're going to store a, sorry, we're going to load a with, what is the location? Is it, that's 28. I should just look this up instead of like trying to guess it from what the emulator is saying. Seems like a better way to handle this. I feel like I used to remember what the address was, but not anymore. 2800 in hex. So load a 28, store a 2006, load a 00, store a 2006, and then we want to write to the background with some values that will fill it with the repeated metatile. So we'll just use X as our main counter. And we have to also keep track of how many times we loop through, because it's more than 256 bytes that we are writing to the screen. In fact, what is it? It's 256 divided by, like, I should know these by now. It's 32 by 30, so that's 960. Like, I should know that by now, but it's been a while since I've thought about this. So, so 960, what was that, 4 times? Come on, stop it. 3 times. 3 times. So, transfer X to A. Store A 2007. Well, load A, BG, loop metatile, store A 2007, increment X, compare X. No. I think I want to do branch if equal, branch if not equal to fill loop, and then increment temp, load A with temp, compare to 4. That's why I was remembering 4, because if it's 4, we're done. Branch if not equal to fill loop. Misspelled fill loop. And let's see, is that, this is wrong because this should be 3 L's. All right, let's camel case it so it doesn't look so weird. We're setting that to 0. We're transferring 0 to X. We're loading, storing, incrementing. And then if it's 0 after the increment, and I'm pretty sure that that's right, that will trigger that. Rather than stepping through the assembler, I'll just do it here, because why not? Load X, FF, increment X, and then that should, we should be able to see, if that affected the flags in the assembler. 0 flag is 1, whereas if it's E, 0 flag is not set. Okay, that's what I thought. Oops. All right. So increment, load, Compare, done. Okay, so this should just fill that background now with a tile. Distracting me. Right, and then let's reload this and this and so the question is param3 being set to 0? It is. All right, let's take a look at the code then. Thought this was going to work first time. Such a fool I am. That's level data. I want load level. Where are you? Okay. From. Don't care about that. Okay, we're in the fill loop. What is this? BG. It's 0, so it's just zeroing out. And temp is also 0. All right, why? I'll bite. Why is it not clearing out stuff the way that I expected it to be? There's 28. Unless, is this one of those cases where I did the wrong byte order because I still don't know? That seemed, no, it seems like that should be right because I know for like the palettes it's load palette, right? It's where is it? F00, yeah. So you're writing in high byte, low byte. So 2800. Oh no, damn it! I was loading the value of address 28 on the 0 page instead of the literal value 28, and that makes all the difference. All right, so now we should be seeing what I wanted. Yes, okay, good. Now it cleared out the background. Maybe a little bit hard to see because I have the debugger open. Let me close this. Game, resume. All right, so press start, and now we actually have a background that's correct. It is blanked out. I mean, it's not correct. It's just, it's what I expected it to do. So now we have lookup. So let's use that to actually transfer A to Y. We can do this just once here for now. Like this. And then what we want to do is we want to, actually we don't even need to, technically we don't even need to do, we could do this. We could load A, lookup Y, that gives us our lookup tile value, and then we can store that into temp2, and then we can just literally do load A temp2 store A. So we can just keep doing that over and over again because it's not going to change. So we don't need to we don't need to compute it every time for what we're doing right now. Except that it didn't do anything. Did it reload the ROM? Yeah. What is the tile that it's using? 3? You know, that might be right, actually, even though you can't actually see anything in tile 3. Well, Tile index 61. Yeah, you know what? That is right, but then we're not adding the offset to it also because there is an offset. I believe it is. We talked about this one other time. There's some sort of like hard-coded offset that is in. But is it in the actual computer? Yeah, I don't. Should have written this down somewhere. 3A. Ah, go away. 3A. No, must be in the tile. So, did I mess up the lookup calculation? That could be. Take a look at what that actually is. So set the address for lookup to rowmem plus y because that's where our metatile lookup lives. Alright, so when we actually go look at that, what does that have? Maybe that doesn't have the right offset because I manually entered it into the file. So rowmem as a word is 9D4D. 94D. And that is just our map type 2 for repeat scrolling, followed by... That's cool that it has the comment in it. Repeat scroll followed by world. This is the metatile to use in the background scrolling. So it's using 3. Okay, but that's not actually correct. Map type 1. Where is it saying the lookup is? Set the address for lookup to rowmem plus y because that's where our metatile lookup lives. But the lookup is... in the map, isn't it? Thought I remembered there being metatile mapping. Yeah, because because the idea was in the map itself, it maps whatever metatile you have to the actual metatile in the character ROM so that they can be shared. So that 3... The 3 isn't wrong, but it's... not right either. This should be an offset into here at like tile 61 or something like that. Be once we get past the title screen tiles that we have hard coded. Right, so 58 is the blank tile, and then so 61 is the correct. So what is that metatile then? I was saying that's metatile 3, but then that has to be turned into an actual tile value, including, based on the offset that we have for the title screen there. So it's really more like, what is it more like? It's more like that's times 4, and then we add the 58 hex to it, right? So we load that, and then we do shift left twice, not 3 times, twice. Multiply by 4 to get the proper metatile index, since each one is 4 tiles. And then clear carry, add carry, 58, add 58 hex, because that's the number of tiles for the title screen. Probably add a to-do. This is, it's bad, this is hard-coded. But that should now give us something a little bit more interesting than, well, actually, it's not. It's going to give us, it's probably just going to give us an empty tile, but a different empty tile. Let's look at the calculation that it does here. So A is now 64. So tile 64 X is what? This one. 2, 3, 4. That seems wrong also. Oh, is it because, let's see. 1, 2, 3, 4. So is it 55 because this is a blank metatile, and then that's where we start actually having the real metatiles? Maybe that's what it is, not 58. That looks to be making more sense anyway. Okay. And I apologize, like some of this is just kind of off the cuff. It's just because literally I'm just kind of messing with it to get it to work in the current state it's in. There's some more stuff we're going to have to do to make it really work. Okay, yeah, so 61 is the right index now. If we go to tiled, what you'll see is this is not the right map. This is the right map. But you'll see that these metatiles, if we go to map 1, they start with an empty tile in the top left, and then you have the little wavelet in the top right, and then 2 more empty ones, and you've got that as your metatile here, right? This is a case where this metatile could be described more. We've talked about this before in other streams a while ago, probably well before I resumed again, where in addition to the reuse of the metatiles that we're doing, we can further analyze the tiles and turn the metatiles into 4 bytes that describe which of the individual tiles to use, so that we can reuse the tiles that are identical. Because there are going to be a lot of them, especially in levels like this where you have water or grass or something like that, and you have like a subtle difference, like you have this wavelet here potentially, but maybe you have another tile that has some other smaller difference or other difference in another tile, and that will help condense the tile set down even further. But that wasn't something we were going to do right now because we were just trying to get things working. So, all right, but 61 is right. The only thing I would like to be able to do is potentially make this actually load. Well, we'll do that. We'll get the actual tile, the full metatile to load, even though then the scrolling part of it is wrong and not doing that. But that's fine because that's what we want to do overall anyway. All right, so now if we go to the PPU viewer, we can see that in the name table we have a bunch of 61s, so that's good. That means we've got the basic background tile loading, and then what we want to do is we just want to loop through. So what we want to do is we want to start with the first tile, go to the second tile, go back to the first tile, go to the second tile. We just want to alternate back and forth. And then once we progress to the next row, so after what is that? 32 tiles, then we want to so first we want to do tiles 0 and 1 and just go 0 1 0 1 0 1 over and over again. Then when we get to the next row, we want to go 2 3 2 3 2 3, right, to draw the whole metatile, because even though the tile is laid out in a, well, this isn't right, but like if this is the metatile here, even though it's laid out as a square with the 4 tiles in the character data, right? It's just a contiguous set of tiles. So we need to do something about that. So at some point we will get these palettes working so it actually looks like it's supposed to, but so making it alternate shouldn't be that hard. I'm just trying to think of like what's the easiest way to do this. So one thing that we can do, which is kind of neat, is we can transfer X to A. Oh. Do we need to do it before we increment? Yeah. So, okay, so what I'm going to do is I'm going to change this logic a little bit, and hopefully you'll see why in a second. I'm done with fill loop. So what I want to do is I want to transfer X to A, and then I want to AND 32. And what that's going to do is, this is a trick we've used before, where if we want to have essentially like what you would use a modulo operator in another programming language, we're using this in the same way, where you're never going to get to beyond 31, because doing this logical AND, it will zero out the bits that are 32 and above. So this will allow us to use this as effectively like a modulo, but a little bit less simple. What we want to do is we want to do an AND, and then we want to do a branch if not equal, meaning that we hadn't reached 32, or a factor of 32. Wait, would that work for a factor of 32? Like if we get 64, get 0, yeah. Yeah, so if we haven't reached, if we went past a factor of 32. Let me think about that. 32, 64, and then what is 96 in binary? Yeah. But then if you do like 95, yeah, okay. This is 1, 2, 4, 8, 16, 32. And then you add, oh, yeah. And then you add 1, and you're going to get 1, 2, 4, 8, 16, and 30. So all of these are now 0, and these are zeroed out because of the and. Okay, yeah, I thought that worked. So if it's not equal, meaning we still have bits set, then it's not a factor of 32. So we're going to go to fill loop because there's nothing to do. If it is 0, then what we want to do is we want to change temp 3 to now we do another bitwise thing here. So we're going to load that with we're going to load A with temp 3, and then we're going to do an OR with the value 2, and then we're going to store it in temp 3. And the reason we're going to do that is, oh wait, not OR A, we want exclusive OR, sorry. And so we need to also store all of those. So yeah, so the reason we're doing that is because basically the first time around temp 3 will be 0, and then once we get to the next row, we're going to do the exclusive OR, which will set the value of temp 3 to 2. Then once we come back on the next row, the exclusive OR will change it back to 0, right? Which is what we want, because what we want to be able to do is we want to load this value, we want to clear carry, add carry, temp 3, which will tell us we're going to actually load this, and is Y in use? We might want to use Y for the other thing we're going to use. Can you do that? No, you can't do that. Okay, that's fine. Do we have a temp 4? Do I need this many variables? Temp is what? Temp is... Actually, yeah, I'm not using temp for anything. Where... Load A0, store a temp, temp 2, temp 3, transfer X to A. Alright, so let's use... So this temp is going to be the main thing we're storing. Temp 2 will be what we're using as a alternating pattern between 0 and 1 for the tiles within the row, and then temp 3 is the alternating pattern we're using for the row in the metatile. So that one is a little bit easier because we're going to do this, and then we're going to store it. We're going to load A with temp 2, and then we're going to exclusive OR. That's the other thing. I was thinking in binary here, but this should just be 2, not 1, 0. And then that's 32, that's fine. So exclusive OR that, and then store that in temp 2. So temp 2 will just be alternating between 0 and 1, and then every row we hit temp 3, we'll be alternating between, between 0 and 2. This should be 0 and 1. This should be 1 for 0 and 1, and this should be 2 for 0 and 2. Okay, so let's see if that convoluted way of doing this actually works. It should. There's not, it's not really, I mean, it's a little bit messy with the bitwise operators, but it's really pretty straightforward otherwise. Just had to reverse that condition to allow for that jump to work because we had added too much code for the branch to work. All right, so let's reload. Let's just take a look at that code in action for a few loops, make sure that that makes sense based on what we're seeing, and then we can let it complete and see what the result is. So run that. Start. Load 0, temp. Okay, so those are all good, and then X gets transferred to A. And then load background loop metatile, transfer A to Y, and then look up, and that's 3. So all of that is unnecessary because it's always going to be 0 in that lookup. So I guess we don't need to go crazy actually looking at what background loop metatile is. It should just be 0. But anyway, then shift that twice, like we said. We're going to clear and add the 55. Oh, that comment is wrong. Boo. All right, so that should be 55, and I should just, anyway, sorry. And then we store that into temp, and temp now has 61. Now at the top of the loop we load it, we clear our carry, we add 0 and 0, so nothing changes there, and we're going to store that. And then we're going to load temp 2, and we're going to do the exclusive OR, so it becomes 1. And then we store that because we need that the next time around. Increment X. It's not 0, so we can now transfer to A and it and see. Oh, no, you silly person. Yes, I had the right idea, but this is not the right way to do that. It's 1F. So we want to check all the bits except for 32, the bit for 32. That was, I knew something seemed wrong about that, but I couldn't put my finger on what it was, and looking at the bits, it seemed fine, but that was what I did wrong. Okay. Yeah, that makes more sense now. So we're just going through all that code we just went through, but now we're doing the and so you can see that A stayed as 1 because the binary value 1 ANDed against 1F, which is just a bunch of 1s. I'll bring up the calculator for those of you who need to see it to believe me. Here it is, all 1s in the first 5 digits here. So 1 is obviously the first digit on the right, and so it just stayed, and it's not 0, so we're going to go back and loop back around. But this time temp 2 was 1, so now we're going to do, we did the exclusive OR, it became 0 again, so now temp 2 is 0, and then we're going to do the AND again, and we're going to keep doing this. So now once we hit a row, we should come here. X is at 32 now, which is what I wanted, right? So like once doing that AND got us a 0 value, it's because we hit a factor of 32, so, or a multiple of 32 rather, and so now we want to flip temp 3 from 0 to 2. So that's what we're doing with the exclusive OR, and we're storing it. And now this math will work out slightly differently because temp2 has a value and temp3 has, well, temp2 is 0 right now, but temp3 now has a value of 2. So now we're going to start alternating between 2 and 3 in terms of what we add. So 61 will become 63 and 64 as we loop through. So that was a 63, and this is now 64. Great. So we're just going to keep doing that over and over again. And then so now X is at 64. Wait, no. 32. Yes, 64. Because F0, 40 is 64. Since 20 is 32. So now we're going to do the exclusive OR to flip that bit off for temp3. Cool. So let me move the debugger out of the way and continue the code. Oh, well, we got some sort of cool effect here, but that was definitely not what I was expecting. Let's take a look at what happened. Oh, that's what we were using temp for. Oh, no. Okay. Let's use temp for, let's use something else besides temp. So temp was being used to count how many times we looped through this fill loop, which that is not going to work. Let's use Y because we don't need to do a lookup anymore. So Y is free at this point. So let's load Y with 0 now. Here. and then instead of incrementing temp, we're going to increment Y, and then yeah, let's just compare Y to 4. And if it's 4, then we're done. Okay. I knew we were using temp for something, but I just didn't look far enough down in the loop. All right. Okay. So we're back here in this code. Let's go down to this comparison. The first time we're down here, Y is 0, we increment it, we compare it, we're good. Okay. So, hey, why didn't that work? What do we actually have in the name table? We have 61, hopefully, 62, 61, 62, 63, 64. Oh, so it is right. Oh, you know what's probably wrong? The attributes. Those lovely, lovely attributes. Because, let's see, attribute data is 0. What is it over here? It's FC. So we need to set the attributes to something that makes sense so that it's using a palette that is going to change the colors of our tiles so that you can actually see them. Or I suppose we can also, you know, just change some palette colors so they're not all the wrong colors and see that at least here. So yeah, so you can see the metatiles got loaded correctly. Although, does it look weird? I mean, it looks weird because it's repeated so often, I assume. Is there a way to see the grid? Show tile grid. Yeah, it's just because it's repeated so often. Like, that's actually, I guess that's a good example of a bad metatile to repeat. Like, maybe we need something slightly different. And where does it, it's filling. Oh, that's interesting. So it didn't do it exactly the way I thought it would. Was my reasoning off in terms of the factor of 32 thing? I mean, it's right for 64 because for 64 you're doubling 32, but for 96 if you and yeah, those 5 bits are going to be, and then those bits are not. No, that's, yeah, it's not that. And then what's after that? 96 plus 32 is what is that? 128. You subtract 1. Those 5 bits are set. Yeah, so that's weird. Why did it do that? Why did it do that? Was something else going on that was influencing that? 2800. This is good. And that one's fine. That one's fine. That one's fine. This one is fine, and then this one is not. 28E0. Oh, it's every time we hit the boundary of what? It's okay. So it's every time we hit a boundary of 256 tiles. It, I guess, it should be flipping. And what's happening is we're getting a row of the correct tiles, and then we're getting a row of the incorrect tiles, and then it's flipping over. So, okay, so that's a logical thing. I didn't think about that. So, yeah, so what's happening is, you know, we're looping through, and once we hit 256 tiles that we've written, we have to then increment y and determine, hey, have we done this enough times that we know we've filled the background? But realistically or logically, if you think about it, once we do that, we should be also flipping to the next row of tiles if we haven't already. And the check is doing it. Yeah, the check is doing this here, because I want to do it after we do the increment of the x to just be able to check. Be able to check immediately after the increment. Let's do this. It's a little bit technically more expensive to do this, but we'll do compare x with 0. And so now we're doing an extra compare so that we don't have to write specialized logic to flip the bit here every time. And then it's just a more logical kind of flow of the instructions. Like, because it always happens here instead of, it always happens here except for when we need to increment y, and then it happens where we increment y. I think that's probably okay. That should make it work consistently across the boundaries now as well. No, that broke it. Why did it break it? Branch of equal, compare x, branch of equal to done with fill loop, otherwise jump to fill loop. What gives? Increment x, transfer x to a, do the and, branch not equal. Okay. Load a temp 3. What did I do wrong? Ah, stop. reload the ROM. And where is load level? There it is. And we want to see, we'll do it here. Just that. All right, so we're just going to compare, which not equal, then we'll do that. So I want to see what's going on here. So it's equal to Grinch, if not equal to, okay, so we hit our first one because X is 2, 0, and then we're going to do our exclusive OR and temp 3 like we need to. And then we're comparing X against 0 to see if we've looped all the way through, and we have not. And so we will now jump back to that. And then we load temp with 61. And then we add, okay. Oh, it's the palette problem. Damn it. That's what it is. It's not the code, it's the palette. I totally forgot about that. So, like I was saying before, the reason we didn't see the thing was because the palette is not correct, and so we've got a bunch of colors that are black against black, and yeah, now it's a uniform set of metatiles. It still doesn't look great, but it's at least what we need it to be. All right, so now why does it start loading tiles in the wrong spot? Like, let's restart the game here and slow down the emulation because I want to look at what's actually happening. I don't care about the tile grid. I do want to see. I don't care about that either. Show attribute colors. Oh, that's cool. So I want to see tile updates, and I don't care about attribute updates, and I do want to see rights that don't update the data. And so now we're running at pretty slow speed, and we press start, and oh, okay. So it's not actually altering those tiles, it's messing with the attributes. Or maybe the attributes are already messed with. But it is wait. Was I seeing that right? Was it updating the whole thing? Because that seems a little crazy. Is it that it was updating the whole thing, or is it just showing the fact that we update? Okay, no, so it's just a weird. Is there a way to shorten the highlight? I don't know. Let's see. I don't know how you would. No. Not sure why it's changing the attributes. Let's reload again. I guess as part of the repeat scroll code. it's updating the attributes incorrectly. So, all right, so let's restart again because I'm trying to understand what exactly is happening here. Rewind this for a second. Slow it down. A row update, attribute update, row update, attribute update. Oh, did it do a row update also? Row, attribute, row, attribute, and row, row, attribute. It's kind of weird, like what is happening with the attributes. I'm not sure why. Like the row updates at least make sense because every row that you hit, it's got to update. But the attribute update is making it look like we are altering tiles outside of the bounds of the screen. Or sorry, within the bounds of the scrolling, which is why it looks like stuff is changing. So maybe... So we gotta fix that. It shouldn't be doing that. It should be... Maybe for repeat scroll, we force apply attribute values across both name tables to avoid this from happening, since I don't even know why it would need to do that. Kind of weird. But the row updates are happening outside of the scroll area. I can avoid getting hit to like kind of watch this for long enough. Although I guess it doesn't really matter if the player is alive or not. Here, yeah, you go crash. Thanks. All right, so now it's at a point where it's not updating the tile data anymore because it really doesn't need to, because see, that's really weird because like this is a trailing. It's not actually updating those. It's just they were updated at some point recently. But it's not overwriting those tiles with anything new. It's the attribute changes that are messing up stuff to make it look like it's not like the tiles are somehow changing, which is really bizarre. It's really strange looking. Like I said, maybe we need to just force the attribute table, the attributes of the two name tables to be consistent and then not touch it for repeat scroll. I don't know. I'm not sure why it's doing that and lagging like that. That's really weird. Okay, so now we're at a point where we're actually doing updates again for real, and this is because we're in the actual map now. We've passed the repeat scroll, so now we get our little island showing up. So that all looks good. We should get to the point where we reach the end of that, and then technically we should stop, but I think it's hitting the end and then forcing a repeat scroll of other stuff. But what I'm curious about is if it's still actually updating outside the scroll view, or if it's within. No, that's interesting. So that's I'm curious to know how much of that is because of the repeat scroll being broken, or if it's because of the way that the map is forced to transition between, because it shouldn't be doing that. It should be done here, right? So what should be happening is it should just stop. But what's actually happening is there's code that says, okay, we reached the end of the level, so go into repeat scroll mode, and that's screwing this up. So if we reverse the order, I'm curious to see what the behavior is, because it should, like, in theory, I would think that this works because it's got real data that makes sense. But let's try it out and see, because it's going to affect what we actually need to work on next. That's the only reason I'm doing this, because it's actually relevant to what we're trying to do. So we should get the map level stuff first now, and then the repeat scroll. Although, now that I think about it, I don't know that we implemented that properly. Well, no, we must have, because, or we did for repeat scroll, but maybe not for the regular map scroll. Well, anyway, that's why we're testing this. Yeah, see, that's what I thought. Alright, so repeat scroll. Proceed with map render, load background mode. If it's repeat scroll, then do that. Right back, branch equal to repeat scroll mode. Otherwise, go to process map mode. So where are we changing it incorrectly to repeat scroll? Swap to repeat scroll. Okay, so this is load background, blah, blah, blah. This is wrong. What it should be doing swap to repeat scroll. If it's a map, swap to map mode is calling load level the correct way. So what we want to do is the same thing that we're doing here, except instead of swap to repeat scroll, like all of this is actually, I'm sorry, this is actually not correct at all, right? What we should be doing is, this part is irrelevant. So swap to, calling something called swap to repeat scroll is no longer relevant, because this is all nonsense now. Yeah, so that's, I'm going to comment it out just in case. Because it is wrong, but I don't want to lose this code, and I haven't committed the code in a while with these changes and the files, so let's, crap. I went too far, and then what I want to do is I want to go down to line 491. Oops. All right, 491, and then this is still relevant, I think, actually, but you know, I don't want to do it all the way down there, because that is kind of far away. So process game, okay. So what we actually want to do here is we want to do what the code is doing here, which is we want to call load level, and then what is this doing? And then this is just setting up, oh, it's setting up the ship with the offset of the camera that's been updated to reflect the new map. So yeah, so let's do this and then comment this so that it actually makes sense instead of the way it was before. So let me see something here. Load level, I believe 0. The parameter 1 is the map we're loading, so that eventually will have to change. The next level offset is good, and then we are not forcing the whole background to be rewritten by setting this. We probably could change that to a constant to make it a little bit more clear, but that's okay. Parameter 2 comes back with our next level offset, so we're storing that. And then what I want to do here is use the new camera position to adjust the player position based on the newly loaded map data. Okay, so, and then jump to process game, because we are done with that. So this is the reason why going from repeat scroll mode to map mode worked, but not the other way around. It was because we had two separate branches that we were doing, and really the process is always the same. It's, okay, look at where we last left off in the map data and figure out what we need to do next based on that map data instead of hard coding it. So let's reload the ROM. And then we will try it and laugh at how bad it is and how broken, and then we will fix that too. Maybe I'll be wrong and it'll actually work, but I'm not holding my breath right now. PPU viewer, we have 2 of you. We don't need 2. We should get a row of like those road tiles, and then we should switch immediately to repeat scroll mode, and hopefully that will... Oh, okay. All right, so that's actually... That's not as bad as I thought it was going to be, because there's some good stuff going on. So one of the things that's going on that's good is it looks like it was repeating, though something maybe not correct about the way it's repeating. I think I said that was probably broken anyway, but it did switch. Now, one thing I did notice is that the enemies have not loaded. So that is... Oh, I know why that is. Because we are... Well, maybe not. I thought it... The reason it wasn't working last time was because of the... Oh, okay. Yeah, that makes sense, actually. So there are a couple of things that have gone on. I think we've probably gone past the level data. And so it's just kind of reading random data right now. The enemy's not loading. At first, I thought that was maybe related to the fact that we have the enemy count index thing. It's possible that it's related to that, but if you remember what happened a couple streams ago, it would process the enemies. They'd come onto the screen, and then we would go right back around and the enemies would not load. Or no, sorry, we'd go to the regular map which had enemies and they wouldn't load, because we never reset the enemy counter. So that meant that we were always we would come back in past the number of allowed enemies, so there was nothing to do. But load level resets that, I'm pretty sure. Right? No? I mean, it probably should. So, like, we had it here, but realistically, I think it should be part of this, because when we what am I trying to say? When we are doing the swap to a new level, we always want to reset the enemy index, right? Like, there's no reason we wouldn't want to do it, at least at this point, because we do want the enemy count to be reset so that the enemies actually load upon switching. So I guess what we should do is see what happens when we call load level to make sure that it's switching to repeat scroll properly. It seemed like it was. It seemed like it was the wrong tiles, but it seemed like we were getting a repeating pattern here, at least a little bit, like this stair step pattern. So that makes me think that it's partially working, although it's weird because we're not seeing the enemies and we're not seeing that repeat scroll working consistently, so maybe not. All right, let's go back to the code and let's go back to load level and let's look at what actually happens the second time around, because that's what we need to kind of see here. Okay, so I think the breakpoint is already there. Yeah, okay. Why is it showing that with a weird offset like that? That's weird. Strange. Okay. Level. I don't know. That's weird. Okay. That's not the one we want to look at. We want to look at it after we've gone past the end of this map. So there are no enemies on this map. At least I don't believe so. Oh, actually. Huh, there are. In fact, there's a couple of things on this map. So that is wrong. That's weird. Is it because spawn point and stuff like that we don't have properly coded? Maybe. I don't know. So coming back into here, we're loading param 3. Oh, seriously? How come? That was really dumb. Super dumb. So enemy index is now 0, the way it should have been in the first place. Okay. I don't know if that's going to fix the problems we were seeing. It probably will. It should. No, we are not seeing those things spawning for some reason. I don't know why. We'll have to look and see if I change the data or something like that caused that problem, but we'll see. That's not what we're focused on right now. It was just an obviously dumb mistake that I needed to fix because it was embarrassing. All right, so param 3. Okay, so we're not turning off. Yeah, so we don't turn off the screen because we're not doing a full screen reload. So load 7 and store that into the scroll counter. Yeah, that's all fine. Param 1. So that's getting the map info here. Param 2 got added in. Param 2 is the next level offset, which 1D. Oh, it's a whole word. Oh, but is it? Param 2. Oh, I wonder. I guess it's okay because it should be... No, you know what? Because you have this byte, and then you have a huge map like this. One byte isn't going to cut it. Where are we storing... Store a param2. I mean, it works for the repeat scroll mode because there's not a lot of data, but for a real map, I wonder if we're even... Yeah, are we even doing this in... We're not even really doing this in the real... Okay. So that explains that. So yeah, so what's happening is for the repeat scroll mode we have 2, 3, 4, we have 4 bytes, right? And we're saying, okay, we need to have a placeholder that says, okay, the next thing that we want to look at is this byte. And that's what param2 was going to be. And we did that because we need to, you know, that's how we're indexing through this level data. The problem is, if you look at this, it's 1 byte, and then it's map1.bin, and map1.bin is, drumroll please, that's how big it is on disk, but it is, yeah, it's, you know, bigger than 1K, so byte's not going to cut it, and then on top of it, we're not even storing the value, we're not even storing the value of this next location here in param2. So that's the reason why the repeat scroll is messed up. One thing I want to look at while we're talking about things being messed up is I'm just curious about this. It says 5 things in it. I wonder why that's not working. All right, I don't want to spend time looking at that right now because we got to figure out a solution for this. All right, so what we're gonna do is param2 is out. Param2 is not. We're gonna have to create a special variable for this purpose because we need it to be a word at least, and it doesn't have to be in the 0 page because it is not going to be accessed that often. So we're good with leaving it alone, but it should be, let's see. I don't remember what low RAM actually consists of, but this should be okay. And what did I call that variable? We're going to, so next level offset is going to go away there, and we're going to put it into this. We're going to call it next level off. Next level, we're going to rename it just so I can find all the places we're referring to it. Current group 0. Are we using this for anything? No. I don't know why this is still here. We probably should do something about that, but that's not important right now. Let me go back and put a note about this. To do what the F is this? Okay. So what we need to do is make a note here that says something like next level pointer is used for the current it's an offset. It's an offset from the base pointer. Actually, so let's call it next level off. Current level offset is used for when we return to the next section of the map. It is updated by this subroutine to reflect the new offset. Let me move this to this and put those there so I remember to look at that. And then param2 is out. Param2 is useless for us here. We say current level offset, and then row mem, add that, store it, store it in level mem, then load that, add carry. Right, that's if in case it that's that trick we learned, that if it actually carries over, it will add 1 to the value. But then we also have to do clear carry and add carry current level offset +1. If that carries, then obviously there's a bigger problem, so I'm not concerned about that right now. And then we store that to row mem +1 and level mem +1. So that takes care of that. And then here, this is for repeat scroll, so this will be fine. Sort into current level offset, and then load a 0 and store it into current level offset +1. So basically, we know that in this case, it's always going to just be a byte because it's so small for repeat scroll mode. So we don't have to worry about the next byte in. Actually, we want to do it this way, right? Because it's high byte, low byte in that order. Okay. But then wait, so then why is it, why are we doing it that way? No, I guess we want to do it the other way, like I had it, to match that. Okay, so that's all good and fine. Now the tricky part is, how do we know what our offset is for this part of the code where we are traversing through the whole map? We want to get to the end of the map. It looks like we're doing some math to determine where that is, because we're using max rows. Let me see, are we using param2 for, yeah, so we're using param2 for the work there. That's fine. But then, let's see, max rows. So we're loading the max rows. And then we're doing this calculation. And that gives us the offset. Shift left rotate, shift left rotate, shift left rotate, shift left rotate. And then store. And that's going to give us the beginning of the last row. And then if we're loading a full screen, we're going to just take it as it is, and otherwise. Okay, so what we really want to do is we want to use the value that we've calculated for row mem here, and we want to add the number of tiles to that address in the next, in whatever that's called, next level offset. So we want to load a row mem, store it into next level offset, and then we want to load a row mem +1 and store that into next level offset again. I gotta rename this here. So that gives us our address there, and then we want to do load a. So this is going to add level mem and row mem together. I don't need to do anything quite so lofty here. All I need to do is add 32. So I want to load a next level offset, clear the carry, add 32. Store a next level offset. Wait, how did that trick work? It was, then you store it, then you load the next thing and you add 0 to it. Right. So then you load a next level offset +1, add carry with 0 to add whatever the thing is that happened, and then want to store that into next level offset +1. So that should give us our full offset to the next piece of data, and we'll know what we can do is we can, I'm going to change the data here just for the sake of my sanity and making it clear that we actually reach the real thing. And I'm going to do dead beef. For any of you who have ever programmed on an IBM system, memory that's been let me think about that. It's memory you've freed in C, gets initialized in debug mode to dead beef in hex. And that's how you know that it's not valid memory for you to use. And then, oh, no. It's memory that's been allocated, right? It's allocated is dead beef, and then it's like FEED if it's been freed. I gotta look now because I don't want to tell people the wrong thing. Let's see. Yeah, no, but there was a reason, though. Where the hell is it? Was it? I'm pretty sure it was... it was freed. Okay. And it's Microsoft that uses FEED. All right. So anyway, so yeah, if you saw yourself looking at a memory range that said dead beef in it, you knew that there was a problem because that was system initialized. So the reason I'm doing that is so that we can check to see if next level offset will give us when added to the, well, is that going to be, yeah, when added to the base address of the level stuff, if that's going to give us an address that says dead beef, which is in this case what we want, but that's fine. Next level offset. I don't know why I Wait, did I switch names in the middle of this? Current level offset? How come nobody said anything? You guys. Or have I just bored everybody to sleep with my stories of IBM programming and dead beef? Alright. Oh, because we had something. Okay. At least I know why. Okay, so this is pointless now. Param 2. That doesn't need to be stored. That doesn't need to be read. Process game. Next level offset is now not a thing. Okay, so that simplifies that anyway, because it's just using the same thing every time. Alright, let's give that a shot, because that is going to be interesting to see. Alright, so where is load level? Need to set the breakpoint before we get there. Also, yeah, I want to see what the current level offset actually has in it. It's a 0. Why does it say it's 0? Is it actually 0, or is it just 206? Go to 206. It is 0. It shouldn't be. Why? That doesn't help me at all. Right, let's restart the game then and see why load level failed. Too much going on in chat to say anything, yeah. Somebody mentioned that they don't want to say anything because they don't want to distract me. When I was talking to them privately, and I was like, that's the whole point of me streaming it, is that if you have a question or something, you should ask, because otherwise I can just sit and program by myself. Okay, so current level offset. Let's take a look at what's going on here. Oh, is it? No, that should be okay. Why are you not giving me a value that makes sense? No distractions are too many. Yeah, I know what you mean. What just happened? Why did it not do this? Branch if equal to load full screen. Oh, because, of course, there are two possible ways they could be doing this. So that's if it's load full screen. This is if it's not load full screen. Okay, so let's grab this code. I guess I don't have to technically reload it since we just stored it. Load full screen. So this is doing the store into ROMEM here, and then we're going to do the calculation there. That explains why that's 0. All right, reload the ROM. Load level. There's this one here. Store it into kernel. Load A. Store that. Load A. Yeah. Then we have it here too. Okay. Start. Okay, cool, good. So we have ROMEM. Oh, yeah. No, this is fine. This is the first one where it's going to be 0 anyway. Okay, so ROMEM is in A5. We stored that, and then ROMEM plus 1 is 9D. So 9D05. Where is the memory tool? 9. Oops, no, not the GeForce Experience, please. 9D05. Okay, so where is our... Okay, so so that is the map data. And there's our dead beef. So, okay, so that is close. ROMEM 9D05. And for anybody who's watching this, if you're a vegetarian, I apologize for the crudity of using dead beef. It's, or vegan. I just use it for historical purposes. So actually, I'm not sure if that is the right value for ROMEM that we want it to be, because it is not at the end of the data. The data is clearly here. Is it different for this? But it should be loading. Oh, it is loading the full screen. So why? Oh, because I jumped the gun and this should be that. And that should be that. So I was a little hasty in my pasting code in, because we do need to potentially increment ROMEM here. I don't know if that was the problem, but it would certainly be a problem. I guess so. You're right. It would be, yeah. And we don't have enough characters for cow, so that's out of the question. So is dead beef redundant? Suppose it is. Alright, so branch carry clear, but it isn't. We increment it, but also I also pasted it in the wrong spot again, because this should be after the branch label. Darn it. A tautology. All right. Yeah, thinking about it, I think FEED was definitely Microsoft, where when you freed memory, that was what the debugger or the debug version of the library put into your memory for you. Okay, so incremented ROMEM plus 1, and now we're going to load ROMEM into A, and it has a value of 8, so that's current offset, so that's 0, and then ROMEM plus 1 has 9E, so 9E08 was what I saw. 9E08, that is not the end of the data. That's not even close to the end of the data, so load A temp 2, clear carry. Oh, so did I'm still too early in this code. What is temp 2? What is the value of temp 2? 5. Oh, and I'm still screwing up the other code that would be here because it's not done doing whatever math it's trying to do. Load A temp 2, clear carry, add that, and then store that into ROMEM. Okay. Now that we're maybe done with that, we can actually deal with this stuff. And yeah, okay. Just so anxious to get at the actual code that we needed, that I was not reading far enough. All right, so our second breakpoint is in the wrong spot, but that's okay. Now we are here, so that is 8 and A3. A308. A308. Yes, that is closer to what I expected. And then we are going to load 8, clear, add 32, so that's A328. A328. Except that's still... What would that be? A3... We added another 20, it'll be A348. What is the actual address we need? We need A3F8. Oh, because we're a whole screen. We're loading a whole screen, so we need to go not to the last row, but rather to the first row that we need to load. So this add is actually incorrect. And we need to add 32 by 20, which is 960, to it. Lovely. Okay, so... Right, that's 3C0. So we need to add C0 first. And then we do this to add the 1 to it. And then we need to clear carry and add 3. And then store it. I think that will give us what we need, because we're going to add the 960 to it. So we already have our proper location. We add C0 to the lower byte. And then if we have a carry, we add 1, and then we add, yeah, that should be okay. Okay, load room M. So just all the same stuff we're doing before, but slightly different. With CB, there is no carry, so we're storing that CB into the lower byte, and then current level offset +1 is A3, and we're going to add that, but there's nothing to add. And then A6. So A6 CB. A6 CB. That's too far by a lot. Why is it so far? Because it's metatiles, not tiles. It's 16 by... I totally screwed that up. It's normally it's 32 by 20, no, 32 by 30, but it's actually 16 by 15 metatiles, so it's only 240. So we don't need to do this. Apologies. Okay. I feel like every time I say this should be okay, I should just know better and assume that something will be broken. So this is now F8. Ah, yeah, that was what we wanted. A3 F8, right? A3 F8. There it is. Good old dead beef. So now that we know that we are actually getting to the data that we want it to be, or to the position we want it to be. Now let's put the data that we actually want there. Although, you know what, I'm going to leave this just because I want to see what happens when we get to the second time we call load level and make sure that it is, in fact, offsetting the way that we expect it to. I guess I should also remove the code that adds that cloud automatically, because as much as I like that little cloud, it's not part of any map data. It's just hard-coded in as a proof of concept for the fact that the sprites actually work. And I think we've proved that at this point. I'm out of seltzer. Okay, so ROMEM is 92.8. So yeah, so it's 1 and then a bunch of data. So we're going to add the offset. Oh, but the offset is not the offset. It's actually the position. I mean, that's okay. It's probably better than having to calculate it. But the thing is that if you have it as an offset, then how do we know when we want to use that as the address versus an offset where you just add to it every time? Furthermore, that's what's happening here. ROMEM is... Yeah, so the fact that we increment ROMEM as we're going and we modify ROMEM as we're going means that we'd have to then pull the original pointer out of the table for the level data and calculate the difference now that we've got the offset here. Alright, so that's fine. Let's keep it an offset. I think I like that better than storing the absolute address. I'm not sure that there's any real clear benefit, but it just seems like what I prefer to have right now. Okay, so we want to do maps low and then maps high using param1 as our index. So what we want to do then is we want to take load a param1, transfer a to x, load a current level offset, set the carry, subtract with carry, low, no, what is it? Low level, what is it? I don't remember already. Oh, maps low x. So we're subtracting that address, and then we're going to, oh, but you know what, we need to do the high one first, because if this doesn't work, or not if it doesn't work, if the carry clears, then we need to subtract it, and what do we need to do? We need to, we know it was bigger than the address. So let's see, so what does that mean? So if we had, do we have to subtract an additional 1? I don't remember what that actually entails. So like, let's say we have 256 and we're subtracting 257. So that would mean we're subtracting, but that's not a good example because the bits the value that we're subtracting from is in the lower byte, not the higher byte. So, right, like what I mean is like the problem is that we're not 256 is just 257 with a 1 tacked in the end. What we really want is something where it's bigger in this byte, for me to remember how this actually works with the carry. So that's what, 256 and then 512 together would give me, so that's 768, right? 768. So 256 minus 7. Oh, well, that won't work. That's bad anyway. That gives us a negative. Okay, so we're not going to worry about that, because if that happens, then we actually have a big problem. Because current level offset should be bigger than the map's high value anyway. So the carry should not clear, because if it does, then that means we got a negative value, and then there's a problem. So we're going to subtract that, and then we're going to store that into current level offset plus 1, and then we're going to load current level offset, and we're going to set the carry and subtract with carry maps high, or sorry, maps low. Now let's see. Yeah, same thing with this. This should, no. This is a case where... Oh, crap. So I was doing it the right way in the first place in terms of the order. That's what I was thinking of. Okay. Sorry. So what I was thinking of is if you subtract 1 byte and the carry clears, you need to borrow. But for some reason, I was doing the wrong byte order. So, yeah. So if you do the subtracting with carry for this, and then... branch of carry is clear. No, branch of carry is set to the next label here. Basically, we're saying we don't need to do anything here, but if we want to decrement current, yeah. This is what I was thinking of. So if we have our carry set and we do our subtract and it clears, we got to subtract 1 from current level offset. Now, like what I was saying before is still true. If current level offset plus 1 is smaller than maps high, that's a problem in the code, or a problem with our logic in terms of like finding the offset, like because the addresses should be, the map's high byte should be just lower, or at least the same as the current level offset plus 1. If it's not, then we have a problem, because it means that somehow we looped back around or something like that, which shouldn't actually ever happen. So I'm just making sure that high is plus 1. It is okay. But in this case, it's possible that your lower bytes have result in a negative, which means you got to carry over by subtracting 1 from this guy. So set carry, subtract, and then store it. So that gives us an offset now. So let's actually look at that and see what the original offset is of the map when we go into load level, and then see what our offset gets calculated as, and we can then make sure that that's being calculated correctly. We got to reload the ROM. Okay, so SBC maps low. Okay, great. So that's this. So the first thing I want to do is take a look at what the values are here. So 42 and 90. So 9042. Let's write that down. 9042 is the address. That's the base of our data 9042, not F2, 42. Yeah, so here's 1, and then here's the rest of the data for the map. Great, so that is fine, and then we're going to get to this point here where we're going to take the row mem and do our calculation to increment it by 1 full screen. And once that's done, now we want to calculate what the actual offset is. So we're going to get the param1. Why is param1 3? Oh, because it was modified and called in. Damn it, that's not going to work, but that's okay. We'll pretend that it was correct because I don't want to have to mess with this for now. So now current level offset is 12. So we're going to set the carry, and we're going to subtract maps. So we're going to subtract what should be 42 from 12. So this is actually the case that we were talking about, where the subtract is going to clear the carry, and that's how we know we got to subtract 1 from current level offset plus 1. So you can see carry got cleared, and we got D0 as our value. So we decrement current level offset plus 1. But I also just realized that I am missing the store to current level offset. So we got to rebuild this anyway. So param1 gets modified at some point in this code. When? In sprite palette loop. Boo. Alright, so then I'm going to do this. I am going to push, before we go to sprite palette loop, load A with param1, and then push it. Now, but we're going to potentially have, are there other places where we can exit, where this is going to be a problem? Yeah, so we would never need it here. Wait, what is this? This is if we're not loading the full screen. Oh, this is going to be a problem too. We'll have to fix this later. But in the same sort of way. So let's just put a comment here. Hey, pull A for the level number that was originally in param1. Okay, so that's that. This is when we're loading the thing and also blanking the whole screen. And thought param1 had what we needed, but it does not. So instead, what we're going to do is we're going to do a pull A here, and then we're going to transfer A to X. And I'm going to put a little note that says the stack contains the value of the level index that was originally in param1. Because that's what we need. And then we fix the other problem with the storing not being done. And the carry. Okay, so that should give us an offset that makes sense now. Hopefully 9042 is probably still right, but we'll double check. And then if we can get this working, I think we're good for tonight. So 47, 9047. I feel like we're playing bingo. All right, so that's the level. Good, that sets X to 0. Load current level offset 17. We're going to subtract, we're going to get D0. We're going to store that. We have a carry clear. So we're going to decrement current level plus 1, which is A4 right now. It's going to become A3. And then we're going to load that, and we're going to set the carry, and we're going to subtract maps high And that is going to then give us our offset of 6D0. So 6D0, that sounds like a reasonable number. And if we add 9D4, oops, we got to go into 9D47 plus 6D0 gives us A417. That sounds, that's different than what we had before. Oh wait, A417, please. But it is correct. Excellent. So that is our offset. So that's great. So now the next time we go into load level, it should have an offset that actually makes sense, although it says dead beef in there, so that data will not work for loading the level, but that's okay. So let's just check to make sure that this is all working the right way. So we load our ROMEM as expected, and ROMEM is 9D47, and then we're going to load and do the current level offset add. So we're going to store that in ROMEM. We added that and stored it into that, and then we're going to load a ROMEM +1 and add the carry to it. Then we're going to add the offset and store that. And so now ROMEM is what? A417, which is we confirmed what we want. So now what's going to happen is we're going to load why is it doing that? Oh, because it's gotta, yeah, it's gotta do its whole thing here. But it's going to load that, and we're going to get DE, which is not valid because it is not one of the map type values, so that's good. So we can fix this and get rid of dead beef. Okay. So now there is this is the correct lookup. Where is the wrong? So there is code. Ah, here. Okay. It's like Navi in Zelda. Hey, listen. Except she's telling you about pulling data off the stack. Slightly more useful than the things that Navi was telling you about in Ocarina of Time. Pull a okay, so what is this doing? This is getting us to the row. This isn't even right. This is the same problem as before, where we are kind of like in a weird spot. We were in the middle of the calculation that was being done. So now, oh really? That's funny. I mean, it wasn't as bad as I think. I don't know. It's been a while since I've played Ocarina of Time, so maybe it is as bad, but it was annoying at times, but it wasn't that bad. I think there were definitely times where if you were stuck or frustrated with like a boss or something like that, and she kept saying it could get annoying, but that was sort of the beginning of handholdy Zelda. That thankfully they got rid of in Breath of the Wild. You know, the thing is, I don't know. We're doing load max rows, and then we're doing 1, 2, 3, 4. So we're multiplying by 16 to get, and storing. We're getting all of the Forgetting how far we need to... Oh, okay. And then level mem is how far... Okay, that's cool. So that gives us... So ROMEM actually has... ROMEM has the... What we were talking about. It's the last row of the thing. The last row of the level. So that's what we want to deal with. But we do want to do a pull A and then transfer A to X to get the... you know, we can leave that there. That's fine. And then... Load A, ROMEM. So that's that. And then we want to add not 32, but 16 to the current level offset and store it, and then load that and add that and store it. And then that should give us the address we want. And then we want to subtract the high mem and low mem. So we're going to, we have X already. So we're going to load a ROMEM, no, sorry, current level offset. I'm working on removing the 2 scenes between dark link death and credits right now with some odd results. What are the odd results that you're experiencing? So load a current level offset, and then it's the same thing as before. We're going to set the carry, and then we're going to subtract with carry. Maps low X, and then we are going to branch of carry is set to the anonymous label, and then we are going to otherwise decrement current level offset +1. Otherwise there's the label here, and then we're going to load A with current level offset +1 and set the carry and subtract maps high with X, and then store that into current level offset +1, and then we have a real offset, and we can return lots of sprite artifacts, sometimes some screens. Oh, yeah, it's always kind of, I don't know, I always kind of have like a panic moment when stuff like that happens, because even though there's a logical explanation for what it is that caused it, you just kind of, sometimes it's not a trivial explanation, and you have to kind of wind back what you did to figure out where it went wrong. So it's a little bit scary sometimes when that happens. All right, so where is, I want both places to have breakpoints. So we have this one, which gets that calculation done there, and then our little hey listen should be somewhere nearby. Hey, oh, did I miss it? Hey, pull A. Why didn't it find it? Because it's not. Okay, that's fine. So current level offset is again 60, which makes sense. All right, so now when we come back in, we should be actually transitioning to a repeat scroll mode. Now that the data is actually the right data and not just the sort of sentinel placeholder values that were there. And then we got to look at, next time we'll look at why the objects aren't loading on that map. It could be because something is messed up in the data from the export being not 100% reasonable at the moment. So, yeah, so let's take a look at current level offset. That's 60 still, so that will give us our appropriate ROMEM location. So ROMEM is now at A432. A432. And that is correct. It's 2 and then 10 hex and 0E. So that is actually right, which is exciting. So let's see how badly this explodes now. I mean, it should be right. Yeah, okay, cool. So it's doing the thing with the attributes in the wrong way. And the enemy's loaded. That was unexpected. Although I will say it did look like it was updating the tiles in, even though it shouldn't have been. That's interesting. So it's a little bit behind. Okay, I'm not entirely dissatisfied with this result. So what's happening is it's updating. Oh, it's off by 1 row. Why is it off by 1 row? It's got to be some sort of like weird calculation thing that's being done incorrectly for the scrolling to update properly. But that is cool. That is a transition between the map and the scrolling, which we didn't have before. So now, in theory, we could do something crazy like this. We could say, go from scrolling to repeat. Map to repeat, and then back to the map. Right. I won't make us sit through it all in real time, but it should work. The game moves through a table of 14 events, but there seems to be important stuff in events I want to skip. Oh, so like something that's like setting game-related flags or something like that that you're not hitting because of the changes to your table, or to the changes to, I guess, not going through those parts of the table. So let's see. Does this now? This will be the real test if this actually goes back into the normal map. I'm gonna figure out how to avoid those stragglers. Oh, it broke. I think my offset for the repeat scroll is probably not right. It definitely shouldn't take this long. So, okay, let's take a look at what's going on with that. Repeat scroll. Current level offset is, it's just using Y, increment Y, transfer Y to A, and store that. We should go look at what is actually happening, or what the value is. Y. Probably just like off by 1 or something stupid like that. Oh, we're so close. Let's see what's going on. It's promising that the enemies still load. I mean, I expected them to, but they could have just as easily not have. So we are going to get through the repeat scroll section, hopefully very quickly. And then we should get to the point where we call load level again and figure out what's going on. Maybe we never do call load level. We should. Or am I just being impatient? Oh, there we go. I was just being impatient. Okay, so what is load level off, current level offset right now? It is 4. 4. Oh, no, it's not just 4. It's, you gotta, yeah, you gotta add 4 to, okay. That was, let's see. So you gotta add 4 to whatever current level offset gave you for ROMEM, and yeah, okay. So how does that work then? It should be okay for the other mode. So because we're not using ROMEM for the repeat scroll because it's pretty basic, I didn't even think about this. So okay, so I mean that's simple. It's transfer that, and then we're gonna clear carry and add carry ROMEM, right? We're gonna store that, and then we're gonna say load A 0, add carry 0. So if it carried over, we're going to add 1 to it, and then we're going to store that into that. Oh no, wait, that's not enough. I mean, that's part of it, but then we need to clear carry and add carry for ROMEM plus 1, and then we can store. Okay. Yeah. Oops. Come on. Oh, stop it. Kind of funny how having the debugger open slows down the maximum it can emulate, even at the higher emulation speeds that you select. Should just have enemies throughout the whole thing so I can know when we get to the end, so like I can have a specific pattern of enemies or something like that. We still got to figure out what's going on with the attribute updates and whatnot. But we're close. We're really close here. Okay. So current level offset is now A440, which seems no. You did it again. You did it again. So, damn it. So I gotta subtract that value now from the level beginning, the beginning of the level, in the maps low and high. Is X still set to? I think it is. Although, actually, there's a bug. Just realized there's a bug in here that if we are using repeat scroll, we need to... Where are we doing that push of param1? Oh, we're not doing that to... Okay, no, it's not a bug. I know, I thought maybe we were messing with param... Okay, no, that's fine. Just for the sake of being careful, let's do this. Let's load a param1 and then transfer a to x, just so we know that that's definitely the right value in here. Branch carry set to here, which is there, and then decrement current level offset +1, and then load a current level offset +1. Hey, let's not forget to store this, because that would be dumb if we didn't. Level offset, so that's that, and then we load that current level offset +1, and we want to set carry and subtract maps high x, and then store that into current level offset +1. Okay. Very good. That should fix that now. Hopefully. Maybe. Possibly. Probably. Zoom. One of these days I'll get back to adding the shadows and stuff. I'd like to keep that in, just to add something really cool to the game, to keep that in there. May not be able to do it on everything, which would then mean we probably shouldn't do it on anything. But we'll see. Maybe we'll selectively do it for different kinds of different parts of the game. Waiting for that breakpoint to hit. Okay, sorry. Alright, so let's check this. Offset now. Current level offset is... wait, why? Why did it do that? That seems too high. How did that happen? What did you do, you dummy? Let's actually look at what I calculated for the offset for repeat scroll mode. Okay, so so it sets it to that. Oh, did I not reload it? I thought was I too busy yammering and I didn't load it in. Certainly looks that way. Yeah, there it is. Damn it. All right. Let's do this. Thankfully, the normal map section is pretty short. Okay. So I'm going to F5 to this. We're going to load current level offset, which is a 4.5D. We're going to subtract all this stuff. Oh, it does carry. Okay. Or it does borrow, I should say. So we load that and subtract that. And we store that, and so current level offset is now a much smaller number, which is 60F. And last time we were at like 94.7, 90. Hi, are you in hex mode or what? 94.7 plus, what was that value I said? 60F, something like that. Where is current level offset is 64. 64. It gives you A4 1B, which A4 1B is no, that is in the middle of the level data. What I actually want. Why is that? A4. Huh. It should be A5, A4 5D, A4 1B. It's possible also though that the high and low mem things are different now. Let's take a look at this. Maps low. It's 98.5. 98.5. So A9 and then maps high. Let me write this down because I'm not going to remember this. 8.9 is the lower byte. And it should be probably like the same thing, 90. AC90. AC90. And oh, that's the address. Wait, that's the address it's saying. Oh, yeah, I'm looking at the wrong thing. A9083. 9083. And that is 90. So 90.89 is that location, which is the beginning of the level. And then, so 98.9 plus, what did I say? Current level offset is at 64. 98.9 plus 6D4 is A4 5D. A4 5D. Oh, it's close. It's... Oh, no, that's right. That's right, because that's map type 1, standard map. And then the map data. Okay, so that means that after repeat scrolling mode, this should work. So we've got our enemies flying through. I guess we could have had a smaller repeat scroll area, but it just seemed like the thing to do to test, since it saves all that space by just having the repeat scrolling. Got that one straggler still. I don't know if it's because of the emulation being sped up. It only seems to happen when I mess with the speed of the emulation. Alright, so we have our offset, which is 6D4. So now it says 1, which is not a repeat scroll. Okay, and then we should get map is the background mode, and then max rows is 69. Yeah, that's correct. I don't need that breakpoint anymore. Alright, so it's loading the tiles at the wrong spot, but it is working. So that's fantastic. That's because probably it's just like a weird off by 1 calculation or something like that for the row in memory that it should be loading. And now what we should get is for the map type, it should be 0, which is not a valid map type. Wait, why did it get 2? Did I make it do it twice? That is weird. How is that possible? What's current level offset? D3D. D3D plus the row mem location of this. So D3D plus D3D is AAC6. So AAC6 is in the middle of data. So somehow that calculation got messed up here. It should just be this. That's it. That's the end. All right. Well, we'll look at this next time. I'm done. I'm tired. We did a lot of stuff. We got this mostly working. There's still some obviously wrong parts with this, but it's way better than it was. So as always, thank you for watching. If you want to reach me, I am on Twitter at Clairvis. I am on Discord as Xelius, Xelius. You can reach me at xelius@gmail.com. Yeah, post a question or comment on the video recording on YouTube. Come say hi at the streams Mondays and Thursdays 9 p.m. We're still in daylight savings. Yeah, that'll be changing soon, but yeah, thanks for joining me. Have a good evening and a good weekend, and I will see you next time. Bye.